Okay, today we are starting with linear differential equation. Now, the general form of a linear differential equation is in the form of dn of y by dx of n plus a1, where a1 is an arbitrary constant, dn minus 1y by d of x power n minus 1 plus in the same way dot 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 plus a power n into y equal to phi of x, where phi of x is a function of x. Now, this is a general form of a linear differential equation. Now, you can divide a linear differential equation into two types based on your right hand side, which is f of x. So, if f of x is 0, we call it as a homogeneous equation. Homogeneous equation. And if phi of x is not equal to 0 and is equal to some function of x called f of x, or anything else, then it is called as non-homogeneous. Makes sense? Non-homogeneous. Now, in this video, we'll try to find how to find the solution of a homogeneous. This is what we are focusing on in this video. So, for a solution of homogeneous equation, first I will assume power 2 LDE. So I'll write it as oh, by the way, before that I'll be writing d in place of d by dx. So d by dx is the representation of d. So d square would be d square by dx square. So like this. This is how even they will give it to you in the questions. So don't get confused here. Now I'll assume I have an equation of power 2, an LDE. So how will that be? Power 2, by that I mean d square y by dx square plus a1 dy by dx plus a2y equal to 0. I'm considering this as homogeneous. Now I'll write it in the form of d. So d square y plus a1 dy plus a2y equals 0. Now what can I do? I can take y common. Y of d square plus a1d plus a2 equal to 0. Now I can send this y to right hand side, and what will I be left with? I'll be left with a quadratic equation. D square plus a1d plus a2 is equal to 0. Now what I do is, since d is d by dx, I will assume d as some random variable as m. So what will this become? M square plus a1m plus a2 is equal to 0. Now I have a quadratic equation. Now as we all know that quadratic equation can have three types of solution, and based on that we can find the solution of this homogeneous equation. Now this, when you substitute d as m, this equation is known as auxiliary equation. In any type of question, for finding solution of homogeneous, you need to find the auxiliary equation first. So now I have three types of solution for this certain thing. One is when my roots are real and unequal. So when my roots are real and unequal, my solution will be y equals c1 e power m1x plus c2 e power m2x, where m1 and m2 are roots of this equation. So when they ask you to find solution of any homogeneous equation, all you have to do is find out the auxiliary equation, and then you just find out the roots of it and substitute it in the formulas which I'm giving right now. So for real and unequal roots, y equals c1 e power m1x plus c2 e power m2x. Now the same way for real and equal, go with r and e. For real and equal, the roots will be bracket c1 plus c2x into e power mx, where m is the real and equal root. Now here this is for two equal roots. What if there were three roots which are equal? Then y would be c1 plus c2x plus c3x square into e power mx. So I think you guys get the point. Now next we'll go for the last type of roots, which is this thing, imaginary or complex roots. Imaginary roots. Now we do know that imaginary roots are always in the form of alpha plus or minus I beta. Now once we get the roots as alpha plus or minus I beta, this solution will be given by e power alpha x into c1 cos beta x plus c2 sin beta x. So this is your solution of a homogeneous equation when it has imaginary roots. I'll just give a walkthrough around the steps. Now your first step would be to write the equation in the form of D. Second step will be to substitute D with place of M and get your auxiliary equation. Third step will be to solve the auxiliary equation, get the roots. Fourth step would be, as you get the roots, you will separate them based on your three types of roots and then find the solution and substitute it in the formula. So that is your final answer. Now let's do a sum based on this. I'll be taking, first we'll do one with cubic or power 3. Okay, so here they have given me d cube plus d square plus 4d plus 4 into y. My first step, I'll send y outside. I'll have it in a d cube form. D cube plus d square plus 4d plus 4 is equal to 0. Now what I have to do, my second step was replace d with m. So this will become m cube plus m square plus 4m plus 4 is equal to 0. Now what I have to do is I have to find the roots. Now even in the exam you'll be allowed to use the calculator, and as soon as you input this equation in the calculator you'll get your roots. Now once I input this equation in the calculator, my roots which I'm getting are minus 1 and minus 2y plus 2y. So I have one real and unequal root, whereas the other roots are imaginary. Now I am pretty sure I can write this imaginary roots in the form of 0 plus or minus 2y. Correct? Now if I take the solution of this, since it is real and unequal root, I can just write the solution directly as y equals c1 e power minus 1 into x, which is minus x. Now for this part, this is in the form of alpha plus or minus beta, I beta, sorry. Now I know here alpha is 0 and beta is 2, so I substitute it in my formula. E power 0x, 0 into x, c1 cos 2x plus c2 sin 2x. Now e power 0 is 1, so this becomes c1 cos 2x. Just a minute. Yeah. Plus c2 sin 2x. Now I have these both as separately. Now to find the solution of the final answer, I just need to add these both. So my final answer would be y equals c1 e power minus x plus c2. I'll consider this as c2 and c3 by the way, because I don't want the constant to be same, because we already use c1 here. So c2 and c3. c2 cos 2x plus c3 sin 2x. So this is your final answer. So now we'll do a question with power 4, power 4 LDE. Now here what I have to do is, my first step is obviously send y to right hand side, and I'll get an equation. I'll directly substitute d as m and write the final auxiliary equation. 4m power 4 minus 8m cube minus 7m square plus 11m plus 6 is equal to 0. Now I have this This is my auxiliary equation. Now I have to find individual root and substitute it in the formula. Now for cubic we used the calculator, but here for power 4 we cannot use that. For power 4 we need to convert this into a cubic and then use the calculator and find the remaining roots. Now to convert this into cubic, I'll need to find one root using trial and error method. So I will be assuming m as anything between -2, -1, 0, 1, 2. I will keep substituting m with these values until I get my final answer as 0. So let's assume here I'll substitute as -1. So if I substitute m as -1 here, so this will be 4 minus 4 plus 8, then it will be -7 minus 11 plus 6, and when you add everything you will get it is as 18 minus 18, which is nothing but 0. That means m is equal to -1 is a root. Now what I do is to convert I use something called synthetic division. So I'll take a thing like this. Now I need to write down each and every coefficient of my initial equation, which is 4 minus 8 minus 7 plus 11 and 6. Now I already know by trial and error method that one of my roots is -1. Now for this method what you do is you assume first value as 0. 4 plus 0, 4. Now whatever value you get here, you multiply it with the root which you found, which is -1, and add it with the second term. So 4 into -1 minus 4, it will be -4. -8 minus 4 is -12. Again -12 into -1 is +12. -7 plus 12 is 5. 5 into -1 is -5. 11 minus 5 is 6. 6 into -1 is -6. 6 minus 6 is 0. Now your final term should always be 0, no matter what. If you don't get 0, then you have to repeat the process again and check where you have went wrong. But in this method, your last term should always be 0. Now I have four coefficients for x. So I can write this in the form of 4m cube minus 12m square plus 5m plus 6 is equal to 0. Now I have written it in the form of cubic efficient. Now all I have to do is substitute it in the input it in the calculator and get my roots. So my first root is -1. So my second root, according to the calculator, it will be my second root is -1 by 2, comma 2 and 3 by 2. This is m1. This is m2. This will be m3, and this will be m4. So I have four roots, and as you see, all four roots are real and unequal. So what I do is I can write it directly. My final answer would be y equals c1 e power m1x, which is -x, plus c2 e power -1 by 2x, plus c3 e power, it will be 2x, plus c4 e power 3 by 2x. This is my final answer. So this is how you have to solve for a homogeneous equation when it has power of 4, and it's an LDE of power 4.